Danny.
Cody be nice.
We're up in the dunny.
The Dunny.
The dunny. What's happening?
Not much. It's kind of a quiet world out there.
I know. It seems so still out there right now.
It is.
It is kind of bananas. Well, hey, last week we dropped a surprise quick and nerdy on COVID-19 and just sort of maybe different ways to approach it. We also talked about how different Enneagram numbers would respond to COVID-19 when the 7 throws a social distance party.
Those 7s, man. You got to keep a close eye on those 7s.
I know, they're always trying to slip a party into something. I love it. So, but for today, we're here for our first actual quick and nerdy that we've sort of planned out.
Yeah.
Or outlined. And we were planning on talking about neuroplasticity. Neuroplasticity. There we go. Yeah. That's a tough one.
You're going to geek out over the neuroplasticity.
Just going to nerd out. So I thought a good way for us to start would be definition.
Yeah.
And then even before that, do you want to outline maybe what we should expect for today's show?
Yeah. So half of the quick and nerdy variable is keeping it quick. So we're going to go through this for the outline. What we're going to do is cover a definition of it. Like you said, that would be a good starting point. Then talk about anecdotes or examples related to neuroplasticity, and then go over maybe some caveats or important facts, interesting facts, and finish by addressing what's the practical application of any of this. So how can you use any of the information we're discussing related to this super nerdy, geeky topic?
This is a geeky one, no doubt.
I love it.
Well, I'm pumped to nerd out a little bit. So what if we do start with that definition? What is neuroplasticity?
Yeah. So neuroplasticity, it's taken on a bit of a watered down definition, but at its core, it's the capacity for chemical expression, brain structure, and brain function to change in response to extrinsic and intrinsic factors.
All right. So if we were to paraphrase that real quick.
Basically, your brain changes in how it performs and in what it looks like in terms of structure and expression based on what your experiences are and how you're thinking. So internal experiences and external experiences affect the way your brain looks from one year to the next.
Oh, it's bananas. So my initial impression is there's some major implications from that. The thing I was wondering is there like an example maybe, or maybe a good anecdote of a person that maybe would illustrate this?
Oh, yeah.
Yeah.
There's one that comes to mind so quick for me because I think it's such an entertaining example.
Yeah.
Also, are you wondering if there's hope for you? Is that
that's definitely underlying everything I'm thinking right now.
You don't need
it's like, wait, I can change this thing? This is great.
You don't need any change.
Maybe in the executive functioning realm.
It works. Your brain works pretty good.
I'm getting by.
So the example that I think is really cool is with Alex Honnold.
Yeah. So Alex Honnold, the rock climber.
Yeah.
Right? Most famously, when a couple of years ago.
I think it was a couple of years ago.
Free soloed El Cap, which is like a 3,000 foot face, basically. Just a massive wall. So basically.
Wall of granite, just straight up.
In 4 hours, roughly.
Yeah.
Yeah. So this person went up a 3,000 foot rock face with no ropes in about 4 hours.
Yeah.
Unbelievable.
Yeah, it is unbelievable.
Yeah. And he has a history of doing this kind of thing.
Yeah. People spend 2 or 3 days doing that climb. So they'll biovac, they'll hang out on the side of the face, sleep there for a night, get up, tackle more of it. He just cruises up.
So, if we're talking, I'm going to go Enneagram real quick.
Yeah.
Safety and security, I'm just going to say Honnold's probably not a 6.
He's not. And actually, that's a good way to say it because his brain is not that.
Yeah.
And so as part of, he famously, this excursion is documented in the movie Free Solo, right? Yeah. And he has other climbs that he's done that are remarkable as well. That probably being the most remarkable one that he's done, but he's done some remarkable things.
Yeah.
And as part of that video, they went and they used fMRI imaging, so to look into his brain. And that's a functional MRI, meaning that they're looking at the blood flow of different regions of the brain to see what's firing. It's a loose way to see what's firing.
Okay. So they perform an fMRI with Honnold. And what is it they're looking for particularly with him?
Well, in particular, I think for that, they're looking at the mechanism in the brain that instills fear.
Okay. Yeah.
So the thing that for you and I says, probably not a good idea to climb up this
Use a
rock
rope.
face without a rope. Yeah.
Or just camp at the bottom anyway. Stay there.
Yeah, what a beautiful wall of rock. Just look.
Just take a photo. Yeah. Just take it in. No doubt. So they're looking at the mechanism where fear is experienced in a sense, right? And that structure is called the
You and I know it as the amygdala.
AMIGDULUH.
Here we go. Here we go with the phonetic.
Amygdala. Yeah. AMYGDALA.
Dr. Be Nice with his phonetic spelling of everything.
Yeah. So what did they
AMYG
AH
DALA.
Anyway.
Okay.
So they throw him in the old machine. They're checking the fMRI. What do they learn from his brain particularly?
And so this is what's insanity, which I don't think the movie went into detail about this. This was actually, I read about this in some research articles.
Yeah.
And the amygdala for him is like virtually not firing. Like to the extent that at first they were like, well, was something broken with this mechanism to begin with? Because it's not firing. Wow. And what's interesting is when they produce results from that, right? They try and use a comparison or a control. That's what experimental design is based on, right?
Yeah.
And so for him, they weren't even basing it comparative to the normative population. They compared him to another high-achieving rock climber. So someone whose amygdala also fired as low, he was there was less blood flow, significantly less function going on in his amygdala than another high-achieving rock climber.
Wow. So they're not comparing him to you and me.
No.
They're looking at someone who's already probably somewhat of an outlier when compared to the normal population.
And then he was an outlier from that guy.
That's incredible. So
it was.
Honnold compared to the normal population, we're talking 0.1% kind of thing.
Oh, yeah. Like 2, maybe 3 standard Ds.
Yeah.
Yeah.
Oh, wow. That blows my mind.
Oh, it is. It's mind-boggling. And then what they concluded based on his report, so it's unfortunate because we can't do a between subject comparison because he didn't have an fMRI before he started rock climbing. He started rock climbing in like early adolescence.
Okay.
And so he obviously didn't have, no one knew what it would mean or what the value would be to having an fMRI for this kid at that point in time.
Right.
So you can't compare, but they actually took some anecdotal accounts from him.
Yeah.
And asked him what his early experiences were like. And he described fear. He described being fearful in his early climbing experiences. In fact, he says he was fearful to both climb. He was fearful to interact with other climbers, and he would experience anxiety going into a climb.
Yeah.
At least based on his description.
Okay. So if I hear you right, what you're saying is that it's not necessarily this absence of fear was consistent all through his life.
So they concluded that the structure did operate differently. So then they're talking about neuroplasticity.
Okay.
They do anticipate that for someone to take on what he has, he probably did experience limited arousal in the amygdala genetically. So there probably was some biological basis to his experience that made it possible to go and do these things that induce fear in lots of other people. Yeah. But he grew that essentially by being in more and more extrinsic or external experiences of rock climbing. And so he faced that over and over and over and over again. Mm-hmm. And it actually altered the function of the structure over time to where it's at now.
Wow. Okay, so something you're saying is really important, I think. One, his fabric, right? The genes that he inherited from his parents maybe set him apart a little bit different.
Yeah.
In how his amygdala would operate.
Likely.
Generally. But then he exposes himself or participates intentionally in an activity, rock climbing, does this over and over and over and over. And then what you're saying, if I hear you right, is that sort of changes the structure of his brain
and the function.
and the function.
So what's really cool is there are three ways, again, if we go back to our definition, like gene expression or neurochemical expression, sorry, that's a better way to say it. So neurochemical expression, brain structure, and brain function are all things that potentially change. And what that it basically means is like when I have an experience, it fires neurochemicals.
Okay.
And if I have enough repeated experiences to something, those chemicals consistently firing that way end up having an influence on the structure. Consider it like a slow drip hitting the surface of something.
Okay.
Eventually, that's going to change the surface of what it's hitting.
Okay.
And so the structure changes. And then what's interesting is when you change one structure in the brain, because it's so interrelated, it changes the function of the brain. So the way that that fires influences the way that it's connected to other things, and other parts of the brain may experience subtle changes or influence from that change.
Wow. So because of the network nature of the brain,
Yeah.
in like the way you outline that with like the slow drip,
Yeah.
it's going to change the structure, and what that's going to do from a network perspective is have an impact on other parts of the brain.
Oh, so geeky, so awesome.
I'm like totally nerding out over here. This is amazing.
Yeah. So there's hope for Cody.
There's hope for me. You know what I'm thinking? Like, how do I get places on time? Is this possible?
Yeah. Well, maybe if you produce like an adversive response to every time that you're late, that eventually your brain will fire in a way that it wants to avoid that.
It wants to. Well, somehow I get pleasure out of being late. I don't know why that is. Some sort of sick jollies. Well, before we get to practical application, maybe you can give me some strategies on how to change my own brain.
Yeah.
Yeah. What if we talked about limitations?
Yeah. Well, so I think there's some important facts or caveats to this, because neuroplasticity has, based on its history, it's something that maybe philosophers or even early psychologists wrote about in vague ways, saying we think the brain may be malleable or adaptable in some ways. Like William James, even Charles Darwin have these quotes that kind of imply that, but there's no evidence to demonstrate it. Except for, I believe it was Charles Darwin may have demonstrated that rabbits raised in captivity compared to rabbits raised in the wild had some atrophy in the brain, so the brains were smaller.
Yeah.
And he was trying to imply like there's a difference in experiences.
So an environmental factor that really accounts for that. Yeah.
Which we'll discuss when we talk about practical application.
Okay.
But so in the late 20th century, and then especially in the early 21st century, there was a lot more excitement about it and people writing about it, and research demonstrating that it happens.
Okay.
And so then it became really exciting because people would say, oh, we can like grow our brains and change our brains. And it becomes particularly exciting if you think about injury. So someone that experiences like a TBI, traumatic brain injury.
Yeah, this to me is fascinating.
Yeah,
in a way.
They can grow stuff back. So if you talk about limitations like you mentioned, we have to realize that doesn't mean you can grow back infinite amounts of stuff, or that it just happens.
Right.
And maybe the best example of this is in your occipital lobe in the back of your head.
Yeah.
That's where a lot of your eyesight and your sensory perception stuff is contained. And if you sever that, there's no evidence to suggest there's coming back from that.
Yeah. So in the occipital lobe, there's a nerve that connects directly to your eyeball. Is that correct? And then so you're saying if that nerve were to snip or to become severed, it's not like your vision is going to be able to, or your brain's not going to be able to maybe outsource that to another part of the brain so that your vision is restored.
There's no evidence of that so far
that we know.
Even listening to neurobiologists and neuropsychologists talk about this, from what I've understood, they don't anticipate that would ever be possible. Based on what they've seen.
I guess I'm wondering, are there some other functions of the brain that would change
Yeah, so then that goes back into what is valuable. So first we have to understand there's limitations. Let me cover two more parts of limitations, and then we can talk about other areas of the brain that may move or shift, it's crazy to me.
Yeah.
And so a couple of other limitations that I've heard spoken about is essentially your brain has limited real estate, and there can be some neurogenesis where nerve tissue grows, but there's limitations to that. So with limited real estate, it's not like you can just grow. If one area of the brain is damaged, it's not like you can just grow that somewhere else.
Right.
There's limited real estate, and if something grows or you develop the function of something in some other region of the brain, you're losing something that was previously there. So it's a limited real estate.
Okay.
And then there are limited structures that can actually regenerate or adapt.
Okay.
Yeah.
Oh, that's fascinating.
And so examples of things are Wernicke's and Broca's area.
Okay.
What are those?
Wernicke's and
Yeah.
Broca's. So those are parts of the brain. My understanding is they're above kind of like where your left eyebrow is, where your left temple is,
Yeah.
that are responsible for language. So receptive language and then expressive language.
Yeah. Receptive and expressive language. Yeah. And so what they've found, and this kind of blows my mind, is that people that have had damage to those regions, and they can go in and look, and the damage is there, and those areas are gone. The structures are actually damaged to the point that they're not functional anymore.
Yeah.
But people still have receptive and communicative speech, so expressive and receptive speech. Wow.
So that's a little bit mind-boggling considering the history of this topic in a way,
Yeah.
right? Because the history would suggest a person who suffers extreme damage to Broca's or Wernicke's is like, that's done.
Yeah.
Like your language is going to be messed up again, whether expressive or receptive.
Yeah.
And so if I hear you right, you're saying that function can shift to another part of the brain,
Yeah.
and then you can still, at least in some form, be able to use language.
Yeah. Yeah. So it's been demonstrated. And the way that they know that is not because they found out where that function was happening, is because the people were talking and understanding language.
Could you imagine the scientist?
Yeah. He's like,
Just what the?
yeah.
What is
like,
happening?
What is going on here?
Yeah.
And so, yeah, it's cool. It's not like they know where that function then came about to be, but that networked, interrelated nature of the brain that you mentioned a moment ago,
Yeah.
somehow those functions get produced elsewhere in the brain, take up some other area of real estate than that area by the eyebrow.
Yeah.
And the person figures out how to make it work.
So I guess for a future area of study, understanding how that shift occurs or maybe where it goes, I mean, that just to me seems limitless. Like if we can figure out that, that does shift, then the how or the where or what.
Yeah. Well, some of what I've heard people talk about this is that they believe that it doesn't just shift in its entirety. They believe that basically different parts of the brain pick up little pieces of slack and work together. So it wouldn't be pursuing it to find out where that structure jumped to.
Okay.
It's basically maybe a little picked up here, a little picked up there with whatever's required to produce expressive or receptive language.
So in essence, the network compensates for itself.
Yeah. Whoa. And the function change.
Yeah.
Neuroplasticity.
Neuroplastic-cities, everyone.
Yeah. So let me cover one other thing that I think is cool, and then we can jump into those practical applications. Is just that we know there are periods in life that have critical growth periods. So to those being toddlerhood and adolescence, there's just tons of physiological growth.
Yeah.
We know that preponderance of our neurons grow during gestation.
Yeah.
But now we know through neuroplasticity that we can also produce neurons after we're born.
Oh, that's great news.
Yeah.
There's hope.
Yeah. So they're in toddlerhood and adolescence, there's massive growth periods. Maybe the best example of that is like what's referred to as the language acquisition device, or how easy it is for kids to pick up language. It is remarkable. They can pick up sometimes like a word a day,
Yeah.
which is just insanity for how rapid that can grow exponentially. So there's rapid growth periods, but we know outside of rapid growth periods that we can help our brains to function better, to be stronger, and to perform better, both in the neurochemical expression, the structure, and the function.
Yeah. So, like specific to language, I think of my girls, they're 4, right? Like, I sometimes feel almost overwhelmed by how quickly they're developing, like you're saying with language acquisition. But if someone doesn't learn something at that age, doesn't necessarily mean that they can't learn a language even at the age of 50 or 60 or 70. It can happen. It's just more difficult.
It is more difficult, sadly.
Yeah.
But that essentially is the brain changing from picking that up.
Yeah.
And so, that language is a good example too of what is the best way to promote neuroplasticity.
Yeah.
So, yeah, I don't know. Where does it leave you? For me, this makes me, talking about this, I geek out about it, and then I think, well, how can I promote this in my life?
Yeah. Well, a couple of things that come to mind, particularly one saying that Daniel Siegel uses a lot. I'll probably reference him all the time through our podcast. Maybe
Dan the Man Siegel.
Dan the Man Siegel, also is 6. He all the great ones, right? Anyway, he's a psychiatrist from UCLA, most famously known for kind of developing the field of interpersonal neurobiology, and he talks about what fires together wires together. Is that right? So
Yeah.
a couple things that come to mind is, one is creating experience where the network is firing in a particular way. New experiences, like novel information, new things, and then doing that repeatedly sort of sets up the network in a new way. So the idea that, again, like we were saying earlier, that maybe you get this going where the network is firing in a particular way, the more that happens, it becomes solidified.
Yeah.
But then it changes by creating new experiences and then doing those repeatedly. Maybe thinking or activity, behavior.
Yeah, or language. If you're learning language, the more you practice it, those networks become stronger, and your brain ultimately changes from that.
Yeah. So what fires together wires together.
But what you're talking about is what's critical. So I think it's the novelty. So if you want to promote health in your processing and in your own neurological experiences, novelty and challenge are 2 of the best ways to do that.
Oh, wow. So something that's a little bit out of maybe your current ability, or like something that is seen as difficult, or something that's new.
Yeah. I mean, I think about, for you and I, sometimes you accommodate my need for that late afternoon white, that pure white cane sugar.
Yep.
And we walk downtown.
Yep.
And you and I have been joking about this. Like, we try and take a new route every time we do it.
I would love to have like a drone footage of us and just watch us bumping into each other on corners of streets and stuff, because we're so used to going a certain way, and then one of us, without communicating to the other, decides we're going to take a new turn, and then we just bump into each other. And then we blame it on, we're just trying to change our brain.
Yeah.
Yeah.
Novelty.
Creating a new experience.
Yeah.
So that, even in my drive to work, could look like driving in a new way, taking a new direction.
Yeah. Tap into what you're doing and then do something differently. It helps you learn. And your brain, that's the slow drip. So there's not going to be a big difference from you and I walking a different route one time.
Right.
But if we perpetually promote those experiences consistently throughout our day and throughout the days of our lives, ultimately that will produce a benefit different than if we didn't.
Yeah. Oh, I love that. So one, you mentioned novelty. What are some other things that, promote neuroplasticity or promote brain health, I guess?
Yeah.
Is that a good way to describe that?
I would think. I don't know. Is it a good way for you?
It feels okay.
All right. Then let's roll with it.
Let's roll with it.
So this is what's interesting, is it comes back to really what we know just about emotional health and general health. It really comes back down to sleep, diet, exercise, and then loving, supportive relationships, a network of supportive relationships.
Yeah. Yeah. Wow. To reference that book real quick again, Deepest Well, she talks about just exactly those things you mentioned. Also throws in mindfulness meditation and another behavior that's been demonstrated to show that through this behavior, it creates or produces changes in the structure and function of the brain.
And some of the biggest changes that those activities produce, it shows that it helps out a lot with the hippocampus or memory. So it really helps with some of that, which helps with fluid intelligence or processing.
Okay.
Which is the thing that we tend to lose over the course of our lifetime, or seems to diminish for one reason or another.
Yeah.
And then, those, it helps with the hippocampus. And then the other thing that it talks about that I read consistently in different studies is it helps with neurogenesis.
Yeah. Yeah. I remember reading one where the aging, it slows aging of the brain.
Yeah.
Yeah.
And that's kind of complex.
Certainly.
Because the idea is that your crystallized intelligence, or the amount of knowledge and facts that you're gaining over a lifetime, that always accrues. So it's not that you're losing facts. You actually have so much that it becomes more and more, the load of processing becomes more and more difficult.
Yeah.
So this will help with some of that processing. So basically, if I were to pull it back out, neurogenesis and the hippocampus tend to be strengthened, which helps with processing. And that's all done through, largely, if you pursue novelty, new and challenging experiences. And then if you rely on some of those foundational things that we know, sleep, diet, exercise, mindfulness, or being present in your experience, and diet.
All right. So some areas of emphasis when considering how to change the structure and the function of your brain in a way that promotes health, just like you said.
Yeah.
And then we had talked in our intro, quick and nerdy intro, that this summer we're going to be doing a mindfulness series.
Yeah.
I would think that a lot of what we're talking about today might show up again.
Yeah. That'd be cool. So just to throw out some resources for this, for people to look into, first of all, we're going to post a lot of information about this, both in the description of this podcast. So check it out there if you're listening. And then also on the gram. Are you going to throw this up on the gram?
I'll throw it up on the gram. Maybe a book cover or something. Who knows?
Beyond #beyond_FLG.
Well, it's not a, okay. Did I hear a hashtag in there? Feel free to hashtag Beyond Flag.
Instagramless Dan.
Still figuring it out.
Boomerang that story.
Yeah, we'll boomerang that story. We'll keep it under 30 seconds. Super chill. Yeah, we'll throw something up on the gram for y'all. At Beyond Flag. At Beyond_Flag.
So check out for resources. But one of the seminal works around this was by Norman Droige, and it's a book that's titled The Brain That Changes Itself, and it talks about neuroplasticity, and it's really when it became a hot topic.
Okay. Voila.
Yeah.
Those are some good resources.
Yeah. So something to look into.
Okay. Well, Dan, does that conclude this episode of Quick and Nerdy on neuroplastics?
Neuroplastics. I mean, we could nerd out forever.
I really feel like I could talk about this all day.
For the sake of others, we probably got to dip out.
We'll probably dip out. Well, it's been a pleasure sitting here in the dunny. For everyone listening to this, we'd encourage you to share with your friends if you find this information helpful or interesting by any means. And then we'd always encourage you to create for yourself new experiences. Do that repeatedly and place an emphasis on your diet, exercise, sleep, connection to others, connection to the environment, link, like, love, laugh.
Yeah,
all that. It's been a pleasure.
Why don't you take us out by shouting us out?
All right. Hit us up on the gram, Beyond_Flag. Again, our Twitter feed has been completely neglected, but feel free to go there. What the heck? Tweet us something. And we also got our website, www.beyondflag.com. Flag spelled
FLG.
All right. Lovies.